Solve the problem. The force of the wind blowing on a vertical surface varies jointly as the area of the surface and the square of the velocity. If a wind blowing at 40 miles per hour exerts a force of 50 pounds on a surface of 500 square feet, how much force will a wind of 80 miles per hour place on a surface of 2 square feet? We're given a relationship between our variables in that the force varies jointly as the area and the square of the velocity. I'm going to let F represent the force. So F is equal to some constant times the area times velocity squared. Force varies jointly as the area and the square of the velocity. In the second part, we're given a scenario. If a wind blowing at 40 miles per hour exerts a force of 50 pounds on a surface of 500 square feet, then we have a question, but we'll get to that in a minute. This second part is going to allow us to solve for our unknown constant K. We're given that the force is 50 pounds. Substitute that for F. Is equal to K times an area of 500 square feet times a velocity of 40 miles per hour. So that becomes a 40 squared. Let's solve for K. 50 is equal to K times 40 squared times 500 is 800,000. Dividing both sides by 800,000 gives K is equal to 50 over 800,000. That reduces, if we cancel a common factor of 50 out of the numerator and denominator, reduces to a 1 over 16,000. So we can write our formula then as force, F, is equal to K, 1 over 16,000, times the area times velocity squared. Now to answer our question, how much force will a wind of 80 miles per hour place on a surface of 2 square feet? So in this formula, let's substitute 2 in for the area and 80 for the velocity. So that force then is equal to a 0.8 pounds.